Welcome everyone to today's webinar, Ramset's Force Entry, Track Installation, and Beyond. This webinar is sponsored and presented by Ramset. My name is Tao Nguyen, AWCI's Education Program Manager. Before we start, a few housekeeping items. Attendance should be on mute throughout the whole presentation. Should you have a question at any time during today's broadcast, please submit it using the GoToWebinar dashboard question box. Handouts are available for download in the Handouts tab. At this time, I'd like to introduce our presenters. Dave Jablonski has been the engineering force behind Ramset for more than 25 years. With deep expertise across product development, validation, and technical service, he holds over 5 patents and have led innovation across the brand. Dave is widely recognized as the go-to expert in Ramset fastening systems. With him today is Chris Pangalo. He is the marketing manager for Ramset product line at ITW Commercial Construction North America. He leads the team responsible for managing both the gas and powder portfolios, with responsibility for driving growth, establishing strategic direction, and leading new product development. So welcome, Dave and Chris.
Okay, thank you very much. First off, I'd like to thank everyone for attending the webinar. So what we want to do today is talk about the Ramset brand and some of the applications that you probably already may know that you can shoot with forced entry type fasteners, and perhaps some others that might be new to you. So next slide, please. So first off, a little bit about Ramset. The company was founded in 1948 to bring what was once shipbuilding and repair tools into the construction industry. Now, a lot has changed since the 1940s. Probably one of the bigger things was in 1992, Ramset brought the first gas-powered track tool to market, and we've evolved that particular platform ever since. Last paragraph there, I mean, a lot of our products here are made in the US, and we'll show you on the next slide here some of that. So we've got a little map. So on the Ramset fasteners, most of everything is made in our Paris, Kentucky facility. Those familiar with the Kentucky area, Paris is close to the Lexington area. So majority of our fasteners are made there using USA steel. So we can qualify for some of the, BABA type government jobs that might be out there. Please see us if you have some of that. Our corporate office and where the ITW Commercial Construction Company is located is in the Glenview, Illinois area. That's just outside the Chicago area. We make some tools in Libertyville, and then in Roselle and Itasca there's some manufacturing facilities for some of the other brands that commercial construction has, Buildex and Redhead. So a lot of your, the blue screw Tapcons are made here in the US. Some of the Buildex tech screws, again, are made here in the US. So we're a USA, manufacturer. We try to do what we can to bring you products made here. So if you have projects that work, needing that, again, please come and see us there. Our parent company is Illinois Tool Works. That's a Fortune 200 company, and they provide us with a lot of financial backing to do a lot of different things. So go to the next slide, please. So now we kind of get into it a little bit. So how does this forced entry thing work? So when we shoot fasteners into concrete, for example, these fasteners kind of create their own hole. You shoot the fastener in, you got a lot of pressure and heat created. That concrete is kind of pushed away and provides kind of a friction or compression hold. And then you do get some heat from that driving application localized around the point. And from that heat, you get kind of a sintering or a bonding. You can kind of see that in the photo there. So it provides a very, very good, strong hold. And then these fasteners are a little bit more than a common 1008, 1020 type nail. These are high carbon steel. They're heat treated. and they have to be in order to penetrate and create their own hole, break up some aggregate that might be in the concrete, and give you that bond shown in the photo there. Couple important things here. Edge distance. When we talk about shooting fasteners into concrete, with concrete being fairly brittle, you need to stay away from the edge about 3 inches. And you'll find that there's kind of a rule of 3 going on here. 3 inches away from the edge of the concrete, with all that pressure of the fastener making its own hole and going in, if you are much closer than about 3 inches of an inch, you'll find that the concrete kind of gives away and the edge might break away from the concrete, ruining some kind of aesthetics or whatever that might be needed on the particular project. So it's important to stay at least 3 inches away from the edge. Fastener spacing, again, here is about 3 inches. So you don't want to disturb the localized bond that's created from that the driving mechanism there, and that spall cone that you see there in the photo. So concrete thickness, again, another number 3 times as thick as the fastener penetration. So generally, with a lot of applications, we'll go 1 inch worth of penetration. So the concrete must be at least 3 inches deep. If the concrete's not 3 inches, at least 3 inches deep, what will tend to happen is that driving action will blow out the back side of the concrete. So we want to make sure we have enough thickness there as to not blow out the back side or crack the base material for that matter on that driving action. Typical embedments when you drive into concrete are anywhere from 3/4 inch, maybe 1.25 inches. So gas tools tend to be about 3/4 inch. With powder, we try to use 1.25 inch embedment depths, and that tends to work out pretty well for most applications. Next slide, please. Now, going into steel. Steel is a little bit different of a base material. So basically, when we drive a pin into steel, the steel around the shank is displaced. We're creating a hole. So we're not drilling. The nail itself is creating the hole. When the fastener goes in, the steel being somewhat elastic, will move away from the shank, and then with it being elastic, that displaced steel wants to take back its own space. So it's going to flow back around the shank. And then if you've got any knurling that happens to be on the fastener itself, that is a very good thing with steel fastening. That provides increased surface area. So all that steel is going to flow in and out of that knurled area and give you increased bond. So there is some heat. I wouldn't go so far as to say it welds itself in, but it does that heat does help that fastener out, quite a bit going in. So edge distance and spacing, there's a little different than concrete here. This is something that we want to take a look at. You want to stay about 1/2 inch away from the edge, and the edge is any physical edge to the center line of the pin. And the 1/2 inch edge, really, if you think about a powder actuated tool or a gas tool or something, that's about the diameter of the fastener guide or the muzzle that the pin exits from. So we want to be sure that that edge of the tool is completely on the work surface so as not to, cause the pin to exit free flight or something like that. Fastener center to center spacing, again, is about 1 inch. So again, if you install a fastener, you want to move over enough to where you can close the tool and not interfere with the previously installed fastener, and that's roughly about 1 inch. We want to make sure that we don't impede on the other fastener in the installation. So steel thickness is pretty important as well, especially with using smooth shank fasteners and powder actuated and gas fasteners. So the general rule of thumb is the fastener shank, or the steel thickness, should be equal to or greater than the fastener shank. So what would tend to happen if it were thinner is that while the fastener would go in, I might put other fasteners in that same member. The first few fasteners might come loose. So that's why that thickness is pretty important. Now we do have some other fasteners, primarily used in a gas tool, that kind of contradict those rules, but it's a unique special fastener. So, but with smooth shank, this is primarily what you want to look at. Really, the thinnest steel you can shoot with a normal powder actuated fastener is about 3/16 of an inch, without having to worry about previously installed fasteners coming loose as you add additional ones on that same particular member. The embedment of the fastener. Basically, what we'd like to happen is the tip of the pin to penetrate the steel. That way we've got maximum surface contact area of the pin. Now, that's not always possible. If you've been out on a particular project or looked at some of the steel beam thicknesses, they go up, an inch or more in thickness sometimes. So we can't always shoot through that. Generally, you can shoot through, 3/16, quarter, 3/8. Once you get to about 1/2 inch thick worth of steel, you've got kind of a partial penetration, value, and you're not really going to get too much. You're not going to get into through steel much thicker than that. And it really has to do with the power of the tools that are available in the marketplace today. So next slide, please. So why do we use forced entry? The number one reason would be speed. Basically, as fast as I can pull the trigger, I get a fastener to come out of the tool. I don't need to drill. I don't need to find the right drill bit for the anchor I'm using. I don't need to manage the dust. I don't need to find cords and hoses to go along. A lot of that relates to that cost-effective square that you see on the screen there. Because I don't have to worry about cords and hoses and dust and drill bits and such, again, as fast as I pull the trigger, I can get a fastener to come out. I can handle light to medium duty applications. We're talking interior partition walls, maybe exterior curtain walls, not necessarily structural stuff, but curtain wall type applications, MEP, conduit straps. There's a lot of different applications that we will talk through a little bit more later in the presentation here. And then these tools are completely portable. They're probably the first portable cordless type tools in the marketplace. Again, I don't need cords and hoses to drag along to drill holes or, mitigate dust with vacuums and such. So it's a completely portable system. Next slide, please. Why we use gas versus powder. So these are the two basic systems that the Ramset brand offers. Gas, you need speed. Again, as fast as I can push down, pull the trigger and let off, I get a pin to come out. Most of our gas tools have at least a 40 pin capacity, so I can do that 40 times. Powder, with a powder magazine, I can do that up to 10 times. So the big advantage for gas is in that bullet point number 3 is low recoil. It's very, very easy to use, easy on the operator, not a lot of fatigue when using a gas tool. However, the downside to it is I'm limited on power. Gas tools, battery tools, such like that would be in the marketplace today are all about a number 2 brown load as far as power goes in comparison to a powder actuated tool. So if you know a little bit about powder, you know that number 2 is low in the spectrum. I've got a number 3 green load with more power. I got a number 4 yellow, a number 5 red, and a number 6 purple that I can go to. So that's the advantage of powder, is I have the power for very deep embedments. I've got the power for larger shank diameter fasteners. I've got the power to shoot into heavy, thick steel. And there are a lot of different reasons to do and need that on a particular job site. Next slide, please. Here we've got a kind of a basic outline of the traditional materials that we can use forced entry type fasteners in. One is solid concrete. That's kind of your most basic material. Here you've got a mixture of Portland cement, some type of aggregate, and water. And so, we hope that the aggregate is not too hard and we can put the fastener in. If the aggregate tends to be a little bit too hard, we do have solutions for that. We can try our step shank pins. The step shank pin is kind of a unique pin geometry or nail geometry where the tip of the pin has a smaller shank diameter than the back side of the pin nearest the head. Now, the theory behind that is that smaller shank diameter kind of almost, gives you a pilot hole, creates a pilot hole for that larger diameter to follow. And that does tend to increase stick rate and get us into difficult base materials. Masonry, or basically CMU block, is going to be kind of your next most common type base material. Masonry you see a lot around stairwells and maybe elevator shafts. Could be, the entire, building is built with that. So here we like to say that gas is best for the performance. If you think back, a couple slides back, we talked about 3 times fastener penetration. So that hollow block there, a typical hollow block, an 8x8x16 block might have an inch and a quarter worth of face shell there. Powder actuated, you have to be very, very careful so you don't break the inside face of the block. Gas, being lower power, tends to work very, very well in CMU block and doesn't have that, doesn't create that possibility of cracking or spalling the inside of the block out. The other thing would be steel. Steel, here we're talking more about, heavy duty red iron I-beams, A36, A572, A992, the stuff that you're gonna find in a lot of structures that create that skeleton that they're gonna build around. For these types, powder actuated is best. Again, we need, it's a very dense material. We need the power to drive a fastener into it. So powder typically is going to be best here. Now your lighter gauge steels, metal studs and such, anywhere from 20 to 12 gauge kind of metal studs. We do have some specific special knurled fasteners that are typically shot out of gas tools that will work in those types of materials. So what we really want to avoid here is solid rock of any kind. Granite, even, large chunk of limestone, different things that, might be on the, at the building site that we're trying to drive a fastener in. Rock is just way too hard. And typically what's going to happen here is if you try to shoot that, the fastener will try to penetrate the material. Typically it will kind of create its own hole, but it will completely spall the face of the rock, probably give you a little shower of small rock chips. The other thing we need to be careful of, that the fastener doesn't free flight. So generally we want to kind of avoid solid rock. You're just not going to get the fastener to stick. Where we kind of see something similar to that happen is in high compressive strength concrete. When the concrete gets above about 8,000 PSI, it becomes very difficult to shoot into. Sometimes you'll see high compressive strength concrete on, columns in high-rise buildings, or, something like that. So those can be a little bit difficult to shoot into, and you'll get that concrete spalling and the fastener won't stick. So those can be a little bit difficult for forced entry. Next slide, please. So here what we've got is one of the more common applications that a lot of you may recognize, interior track down to concrete and or steel. And for this application, we use our, like to promote our T4 mag tool. Again, it's a gas tool. We sell fasteners in packs of 1,000. You get 2 fuel cells, you get 1,000 fasteners, and that's usually enough to drive everything. The tool also does have a lithium ion type battery. This tool is unique in that it does have a battery and fuel gauge in the back of the tool. There's a little round button at the back that you can push and see the level of the battery and or gas that might be in the tool. So you'll never run out. You pay attention to that, and it's a good, neat feature to have. T4 mag is a pretty powerful tool. Is one of the more powerful tools, of its kind in the marketplace. A couple different advantages. It's got a nice tapered front housing, gives you a good line of sight for the operator when they're kind of working overhead. That's important where you want to know, placement of where the fastener might be. Low pushdown force. It's a very easy tool to compress. We only compress the front end about 3/4 of an inch. Pull the trigger. Low recoil. It just is a nice tool for the operator to use on a daily basis. Next slide, please. Another common application here, more so for our powder actuated tools, would be curtain wall clips. You can see that there on the top right photo. There's a curtain wall clip being shot up to a steel beam with a powder actuated tool. And then in the lower right, you kind of see an exterior perimeter track application. These, would be shot typically with powder actuated because of largely a specified large diameter deep embedment type fastener, anywhere from 1.25 inches to 1.5 inches in some cases. So you will need the additional power in these particular applications. The RA27 is a very, very comfortable tool to use. The automatic spring return and the push down force of that is a very, very smooth type tool. I think it operates a little bit nicer than a lot of tools in the marketplace. It does have an optional magazine on the front that, you can shoot 10 fasteners, corresponding with the strip load of 10. You've got colors there, green, yellow, and red, different power levels. The tool does have power adjust. A unique feature to this tool, unlike many others in the marketplace, is it does have a scaffold hook. So in that top photo there, you can kind of see that the little bar on the scaffold. The tool will hook onto that, and the construction person can, put up those clips with the vice grip there and then grab the tool. Everything's at, very, very handy to him. Doesn't have to put it down on the ground and bend over. It's just a neat feature to have. The RA54 tool is, again, going to be for those deep embedments, longer pin lengths. It's where we're going to need power. It's our only tool that will take a number 6 purple load. So that might be where we're driving into, real thick, heavy steel, or we might need an 1.5 inch type embedment depth and some difficult concrete. We might, use that tool with that large purple load. Next application, please. Next slide, please. Here we got specialty applications. And so these are some of the things that maybe you weren't aware of that you could potentially shoot. Some of the more uncommon things, insulation, gypsum sheathing, lathing for stucco or something like that, metal to metal, and then overhead. Next slide. So going into it, we've got the JipFast tool. And this tool is designed to shoot either gypsum sheathing or plywood up to light gauge metal studs. So gas tool here, it has a coil magazine to it with a coil that has 150 nails. And the nails have a unique barb to them. We'll see that in the next slide. But basically, we load this tool up, and we've all seen the different colored sheathings out in the marketplace. You've got the yellow Georgia Pacific there in that slide on the lower right. There's purple and green and white and all sorts of different colors that coordinate with different manufacturers and different brands. So it's much quicker than using like a traditional S12 screw for the application. Basically as fast as I can push down, pull the trigger, I get a fastener to come out. So if we go to the next slide, we talk a little bit more about that. So best practices for the G2 tool. So you can see there in the top, the coil kind of floats in the magazine. The nail itself has a very aggressive barbed knurl to it. And so what tends to happen is as you shoot the light gauge material, the metal petals on the backside, and then that barb kind of interlocks with that petaled metal, which gives you that pull-out resistance, in those light gauge. The sweet spot here really is going to be 18 gauge, 16 gauge, and 14 gauge. It can work in 20 gauge and it can work in 12 gauge. There may be some slight issues you may have to overcome in either the light material or the heavy material, but primarily we'd like to kind of keep it 18, 16, and 14 gauge if possible. So with the gypsum sheathing, it's important that we don't break the sheathing paper. So in order to do that, we've got a depth drive adjustment. You can see that in the lower right-hand side photo. There's a little thumb wheel adjuster. So when you first walk on the job site, it does take an operator with a little bit of attention to detail to set up the tool. You're going to want to set that, make a couple test fastenings, set that drive level adjustment to where we're just sitting on the drywall, maybe dimpling it a little bit. We don't want to break the paper. Now that drive depth adjustment might need to be adjusted throughout the job. And some of that adjustment would be if you've got different stud gauges that are in the wall. Sometimes they like to use heavier gauge studs around larger windows, around corners or something like that. I might need to crank that thumb wheel adjuster and make the adjustment on the fly, with that. The other thing would be is your placement of the nail. Am I on the hard side of the stud or the soft side of the stud? So the soft side would be the open side of the stud, whereas the hard side is where it kind of goes back and returns. I've got less deflection on that hard side of the stud than I would on that soft side. So where that could be an issue is with some board tightness. We want to be sure that that board is kept tight to the stud. And if we manage to try to hit that hard side of the stud, that the system works very, very well. Plywood and OSB sheathing, the system works very well. It's a little bit more forgiving. We don't need to be quite on top of that drive depth adjuster. We can be a little bit under the surface of the plywood, or a little bit high, and it won't necessarily affect the installation of the plywood or the OSB in typical applications. So not as much as the gypsum sheathing with the paper. So it tends to be a little bit more forgiving, and we tend to see a lot of plywood being used, either maybe roof sheathing, the first bit of wall that would be on a multi-story building might be done in plywood rather than some of the gypsum sheathing. So next slide. Lathing. So a lot of different places in the country, Arizona, Florida, they're going to, put lathing over maybe a CMU block type building or whatever, whether it be to remodel or to put stucco or something like that up. Sometimes in different buildings, we'll see them use lath around metal columns for fireproofing. So our gas tools can, be used in these applications. You've got the Jip Fast there with the coil nailer. You've got the T4 mag tool and the TF 1200 tool. There's an optional magnetic nose piece that would need to be added to each one of these tools to do the lath application. But basically, you would load the magazine as normal with your pin of choice. And then once you have the adapter on the front end of the tool, the adapter is a magnetic adapter. So those lathing discs there, the round metal discs shown in the photo, they would stick to the front end of the tool. Basically, before every shot, you're going to put the little lathing disc on and then go over the metal lath, and that kind of holds that in place. The normal nails of a gas tool, the head diameter is only about 1/4 inch, and powder it's about 5/16. So this lathing disc, is about 1 inch in diameter and gives you some decent holding power with that lathing system. Okay, next slide. Okay, another one application here is insulation. As different building owners try to improve the efficiency of the building, they want to use more and more insulation added to the interior, exterior of the building. So we came up with this insulation tool, probably goes back to, I don't know, maybe around 2010-ish when we kind of came out with this. The pins here are made in Canada. And I should say the fastener is made in Canada, whereas the pin that goes in the fastener is made in the US. So you've got, we'll have another better look at the cutaway view of the fastener, but here we've got kind of a unique looking tool with a long nose to it. And the reason for the long nose is to go into different thicknesses of insulation. So with the IF compact tool here, we can shoot up to 6-inch thick insulation. Now the fastener used here is going to have, see the white and the black fastener, the stem length on that particular fastener is going to correspond with the thickness of insulation we're going to shoot. So if we've got 2-inch insulation, you'll probably have a fastener that looks very similar to what's in the photo there. If you've got 6-inch thick insulation, it'll look similar to that, but that stem that comes off the bottom of the fastener there will be 6 inches long to correspond with that 6-inch thickness. So here we can shoot 500 fasteners with one fuel cell. That's kind of what our pack size is on the IF fasteners. Big advantage here is if you're used to using stick pins, you've got to glue those, put those onto the surface, let the adhesive dry. You've got a wall full of nails sticking out. When you go put the insulation up, there's a, potential, point of hand injury, or you can scrape an arm or something like that. So, we like to recommend this over the stick pin just for almost safety purposes. It's a very, very easy tool to use, very low recoil, works in a lot of different applications. Next slide, please. Here we have that cutaway view on the lower left. We've got two different types of fasteners here. We've got a white fastener and a black fastener. So the white fastener is going to be for concrete or block. Basically, you've got 1.25 inch nail that's inside the bottom of the fastener, and doesn't matter whether it's a 1-inch long IF fastener or a 6-inch long IF fastener, it's going to have that same 1.25 inch nail to give you about 3/4 inch worth of embedment into the concrete or block. So it can work in post-tension applications and a lot of different things where some embedments are limited. So basically the black work contact element, or the nose piece, goes into the bottom of that, the stem of that fastener, drives the fastener in place. You pull that out, and then there's a cap that goes over the hole there, and that cap is built into the fastener itself, it snaps into place and makes the entire fastening thermally efficient. The building owner loves that. The architects and engineers love that. Basically you're not exposing that fastener, that metal fastener at the bottom, to any of the weather. It completely seals that particular cavity off, giving you thermal efficiency. The black fastener there is very similar to the white fastener. We colored it different to work in basically steel studs or wood. So the difference there would be the pin inside of the fastener itself. We've got one of those, helical knurled type fasteners in the bottom there, and that will work in steel studs. Again, your sweet spot is going to be 18, 16, and 14 gauge type material. The same black cap is in there. And because the system can do, concrete, block, steel stud, or wood, it's very, very flexible for most any applications. We're one of the few people in the marketplace that has the ability to do all of those particular applications. You can see there off on the right side some of the various insulations that we can shoot. XPS, all the different colors, the pink, blue, and green corresponding with different brands. The EPS insulation, which is kind of white styrofoam, kind of like a styrofoam coffee cup. We see that in some places. The polyiso insulation is the foil face stuff. There's rock wool, and then there's fiberglass blankets, and we see that in the interior of maybe a tilt-up wall building, or a lot of residential applications. You'll see that fiberglass blanket being used. Next slide, please. Overhead. So overhead would be somewhat of a common application, I guess, for the acoustical contractor. Those of you in AWCI that do a lot of acoustical stuff will probably know the Viper tool. It's a very unique tool in that it's an overhead only tool. It's catered more toward the overhead contractor. So we've got a small, very lightweight balance type tool that is used overhead, comes with some different extensions. It is a powder actuated tool. We can do power levels 3 through 5, so green, yellow, and red. All of our pins, ceiling clips are made in the United States. So if you're hanging acoustical grid, this is a very good tool to use. You can kind of see there in the lower right-hand side, a picture of a ceiling going up. A lot of times the acoustical guy is one of the last trades, on the site. They're after the HVAC guy, they're after the electrician, the plumber, and there's a lot of stuff up in the ceiling. And so, with this tool being so small and compact, you can get into a lot of tight spaces with it. And it just works very, very well. Next slide, please. So a couple best practices for the Viper 4 tool. So the tool is a little sensitive in the way it likes to be operated. It's designed to be a push-push type tool, where you place the tool up against the ceiling in the location you want. You compress the front end of the tool. It's a spring-loaded front end. And then the trigger for the tool is built into the pole itself. So there's a sleeve on the bottom of the pole tool that you would slide up, and then the tool will actuate or fire. A lot of times operators will try to do that all in one motion, essentially trying to stab the ceiling. If you try to do that all in one motion, you do tend to get a little bit more misfires. You'll get maybe one or a couple that'll go off in a strip and a couple that won't go off. So if you're purposeful in the motion and the way the tool is operated and using that push-push, it will go off each and every time. With the trigger being built into the sleeve, it's a very, very safe tool. It's a lot different than maybe, if you've looked at or used Viper tools in the past. This has been, was redesigned probably a little bit more than 10 years ago, but some people may not know that that trigger is now built into the sleeve of the tool here. So next slide. Okay, another specialty fastener we have here, we call it the Tech 034 pin or the Tech pin. And this is used in metal to metal applications, where you might be assembling, a lot of repetitive things like box headers or jam studs, to a specific design requirement on the drawing. You can assemble those off to the side, bring them up, and then put them together with screws, or you can, use the Tech 034 fastener if that, works in the application. So it's a unique 3/4 inch long fastener. It's got a unique helical knurl to it. Works very, very well again in that 16, 14, 18 gauge steel. So the coalation there is a unique breakaway type coalation. So if you've ever used a gas tool maybe to install track before, perhaps you've seen a little, plastic donut trapped underneath the head of the fastener. With this breakaway coalation, you don't have that. It's designed to be brittle, and then when the head of the fastener exits the tool and goes up against that material you're fastening, that coalation, rather than being trapped under there like a donut, is brittle and will break away. So it gives a nice, clean, flush finish. So if you're applying something over the top of it like drywall or maybe a building paper or something like that, it works very, very well in those particular applications. So this is a relatively new fastener for us. It's only been out for a couple years. It's shot out of the TrackFast TF 1200 tool. Next slide, please. So another special fastener here, again shot with the TF 1200 TrackFast tool, is for the attachment of plywood to light gauge metal studs. Basically, we took that Tech 034 fastener and then made it longer. So this basically, you can shoot 3/4, 5/8 plywood to metal stud without much of a problem. Again, your sweet spot again here is 14, 16, and 18 gauge steel. And load up the TrackFast tool. Takes about 40 pins, and you can do this much, much quicker than screwing. If you've got special requirements for fastener spacing due to wind loads, I mean, you can put these fasteners as close to 2 inches apart. And there's data, kind of to support, the application in that. So it works very, very well and much better than traditional screws, and essentially, drives job site speed here. Next slide. Here to kind of recap, it's a good slide that shows kind of the gas and the powder platform that we offer at Ramset, all the various tools, and some of the trades and applications we gear each tool toward. So if there's something on there that might meet your needs, please contact us. So next slide. So as we kind of wrap it up here, so we're here to help you out. Hopefully, maybe there was something here that sparked your interest. There's a lot of information at ramset.com, a lot of different fastener and tool sell sheets and brochures that you can download. Different performance data. You're interested in that Tech 034 pin or the PLY pin, there's data to support all of that. And then if you've got questions on any of the information provided there, or questions about something you heard today, you can call our tech service. The number's listed there. There's an email. I'm also one of the people that will answer a lot of those technical questions. So you may get the opportunity to talk to me on some of that stuff. So, and then if there's something there that you find that you really like and you want to purchase, contact our sales team. I mean, there's quite long email there. You don't necessarily have to write that down. That's on the Ramset website. You can click on the link and it should open up in your email browser of choice, and that you can send an email directly to our sales team. So that about wraps things up. Next slide. Thank you for the opportunity here. And then I guess if there's any questions, or Chris, do you have anything that you might want to add here?
Nothing to add from my end, but yeah, if we have questions from anybody attending.
Yes, we have a few coming in here. Let's start with number 1. So what range of insulation thickness can the insulation fastening pins handle?
So we have fasteners, the thinnest insulation that we can do with those is 1 inch thick, and the thickest is 6 inches. There's an inch, inch and a half, 2, 2.5, 3, 3.5, and there's a 4, 5, and a 6 inch length.
How do you select which gas tool to use for a drywall track installation?
A lot of it will depend on the type of application that you are wanting to use. If you are interested more in longer fasteners, we're going to steer you more toward the TF1200 tool. If you are in the traditional drywall track to concrete, we're going to put you into probably the T4 mag tool. That's probably one of the better tools, if not the best tool in the market to install drywall track.
Next question. Does one need to get certified to use the powder actuated tool?
Yes, that's a very simple process, and the reason to certify for that is an OSHA requirement based on an ANSI A10.3 standard. So that requires all powder actuated tool users to be trained and certified on the tool they're using. If you go to the Ramset website, there's a powder actuated tool training and safety course. It takes about 20 minutes. You run through the course and take a test afterwards. Then you can print out an operator's certificate right there. And then the email that you provide with some of the information that we ask for, it will email you that same certification card to that email address. Very simple process.
Great. Next question, how much tensile load does a T4 pin provide, and how does that compare to a powder pin?
So performance is going to vary depending upon embedment depth and base material. Generally, you're going to have probably similar performance if we're at 3/4 inch embedment between a powder fastener and a gas fastener. Where you gain performance is in the deeper embedment depths typically. So it's best to go back to, say ramset.com and download some of the performance submittals that we have, and you can kind of, compare and contrast the difference between the two.
Great. So that concludes our Q&A portion. Thank you, Dave and Chris. I'm going to send it back to you for closing remarks that you might have.
Sure. Well, I'd like to thank everyone for joining us today. We hope that you learned something new, whether that was gaining some additional knowledge about how Ramset forced entry fastening works, or how this technology is used to support a broader set of applications beyond the installation of drywall track, right? We talked about insulation, gypsum board, lath, plywood, acoustical ceilings. Regardless of the application, using Ramset is going to help you drive job site speed. Ramset has a long history in forced entry fastening, and we believe that our deep expertise has allowed us to offer one of, if not the best, product portfolios in the market, all while continuing to be a proud supporter of U.S. manufacturing. And so we hope that you guys have a great afternoon. Thanks again for joining us here, and a big thanks to Dave for walking us through all that.
Yes. Thank you to Ramset for sponsoring this webinar. Thank you everyone for attending. We'll see you next time. Bye-bye.
Thank you.